Okay, hello ladies and gentlemen. Let me introduce myself first. My name is Ninda Muktiardiani from Department of Architecture Universitas Multimedia Nusantara. Today, I want to present my research which titled Implementation of Passive and Active Design Strategies for Energy Efficient Office Building in case study at VOZA Office Tower, Surabaya, Indonesia. So, my research is on digital modeling, simulation, and fabrication topic because it will use edge software to perform the building energy simulation. Okay, the first part of my presentation is introduction. I will start by explaining the issues. So, there are two main issues related to energy efficiency in the building sector. Firstly, according to International Energy Agency, Indonesia is the biggest energy consumer in the Southeast Asia, which consumes 36% of Southeast Asia's total energy use, or equal to the energy use of Thailand, Malaysia, and Singapore combined together. So, secondly, the building sector absorbs about 40% of total energy worldwide. Even in Indonesia, the building sector is responsible for 50% of total energy expense and more than 70% of total electricity consumption. Okay, so there are two issues which can be concluded. First is the dependency of fossil fuel as an electricity source, which fetch with the increasement of electricity consumption. Second, this condition will also affect the increasement of carbon emission from fossil fuel electricity generator, which mostly used by building sector. So this situation makes the energy efficiency policy and the use of renewable energy sources become an urgent issue. Energy efficiency is significantly important to reduce the energy consumption and cost, also to reduce carbon emission, especially in the building sector. Okay, then more specific issue is office building become a potential electricity consumer in commercial sector. Office building also become one type of building which has 25% of energy efficiency potential greater than the other types of building. Okay, and based on the SNI data, in 2000, the average energy consumption of rental offices in Indonesia are 250 kilowatt hour per square meter per year. But in 2017, the UN International Forum of Sustainable Development, the building energy consumption was even targeted to 90 kilowatt hour per square meter per year by 2030. This situation makes the energy efficiency is significantly important to reduce the energy consumption and cost, also to reduce carbon emission, especially in office building type. One way to make the building more efficient is to implementing the passive and active design strategies. So, the purpose of my research is to give the passive and active design recommendation on the study case building at VOZA Office Tower located in Surabaya, Indonesia. This research also aims to conduce about how far those design strategies implementation could reduce the building energy consumption. Okay, next is the step of the research. So there are 5 steps in this research. First is collecting data, which include the building information and the weather data at case study location in Surabaya. Second is data analysis, which using edge software to perform the simulation of existing building energy consumption. Then, the third step, after analyzing the existing building energy consumption, is to conduct the design strategy, which is including passive and active design strategy to reach the energy efficiency. Next, the first step is doing simulation with edge after implementing the passive and active design strategies. The target is to reach the 90 kilowatt hour per square meter according to 2017 UN International Forum of Sustainable Development benchmark. And then the last is to conclude the finding of the research, including to know how far the design strategies implementation could reduce the building energy consumption. Okay, so I will explain the step one by one, starting with collecting building information data. So on the case study building is VOZA Office Tower, which is located in Surabaya, Indonesia. The building has 64,000 square meters area, which 2 basement, 7 parking floor, and 23 rental office floor. Okay, the next data which will be collected is the Surabaya weather data from Meteoblue website. So the rental office building is located in Surabaya, which has a hot climate as in on the diagram side, which average temperature is about 32 degrees Celsius when it reaches maximum peak point. So with a lot of sunlight, this building should be able to maximize the use of light, natural lighting with proper shading at the window, so it won't cause glare and could also reduce the heat absorbed by the building. In the hot climate also makes the possibility for using solar panels as option for renewable energy sources for energy efficiency. Then the next step is data analysis, which will using Edge software to perform the simulation of existing building energy consumption. Okay, so this is the result of the existing building energy consumption. The total energy use of existing building is 136 kilowatt hour per square meter per year. It's much better than the SNI standard, which is 250 kilowatt hour per square meter per year, but it doesn't reach the 90 kilowatt hour per square meter per year, according to UN International Forum on Sustainable Development as the benchmark. As we seen on the diagram, the most energy consumption is for the cooling system, which reach 65%. This happened mostly because the orientation of the widest side of the building, which is 55 meters long, is facing east and west. Plus, most surface area of the building envelope are made of curtain wall, which using less as the material. The next most energy consumption is for the office appliances with 29%. Mostly, it is influenced by more than 80% area for each floor, which is used as a rental office with 10 hours of working time from Monday until Friday and 7 hours for Saturday. Then the last energy consumption is for the lighting, mainly because there are more enough natural lighting through the curtain walls, which means of glass. Okay, the next step is to conduce the design strategy, which is including passive and active design strategy to reach energy efficiency. Okay, this will bring us to research analysis. The most energy used is for cooling system. So, the passive design will be implemented to reduce the cooling load. Passive design strategies help us maintain thermal comfort inside the building without the use of electricity as heating and cooling require the most. So, the passive design strategy recommendation are to reduce window to wall ratio or WWR, give external wall insulation, give external shading device, and using higher thermal performance plus for the window. So the first thing is to reduce window to wall ratio because windows are usually weak link in the building envelope, as glass has much lower resistance to heat flow than other building materials. Then the second is to give external wall insulation. Insulation is used to prevent heat transmission from the external environment to the internal space from warm climates, which aids in the reduction of heat transmission by conduction. Then the third is to give the external shading device. Nah, the external shading device are provided on the building facade to protect the glass element from direct solar radiation to reduce glare and to reduce radiant solar heat gain in cooling dominated climates. Lastly, the use of the higher thermal performance glass. So the addition of low E glass coating to glazing could reduce the transference of heat from one side to the other by reflecting the thermal energy. Double or triple glazing or low E coating could reduce the solar heat gain coefficient and thermal conductivity or U value of the glazing. So it will reduce the temperature of the building. Okay, there are also recommendation of active design strategies. Active design strategies use purchase energy, including electricity and natural gas, to keep building comfortable. The first active design strategy proposed is using cooling system energy efficiency with water cooled chiller. The efficiency of water cooled chiller is typically higher because of the higher heat capacity of water compared to air. Next is the using of energy efficient lighting system. Efficient lamp that produce more light with less power compared to the standard incandescent bulbs, reduce the building energy use for lighting. Due to the reduction in waste heat from efficient lamp, heat gains to the space are also lowered, which is turn reduce cooling requirement. Okay, lastly, the active energy strategy. The active design strategy is using solar PV as the on-site renewable energy. So several systems for generating electricity from renewable resources are available at varying levels of efficiency. Abundant sunlight on set location also make the use of solar panel possible as an option for renewable energy sources. From the simulation, the assumption is the solar PV could cover approximately 25% of the total building energy consumption. Okay, so after conduce the energy design strategies, the next thing to do is the building energy simulation with edge software. Okay, this simulation is to calculate the final energy use of the building after the implementation of the passive design and active design strategy, which targeting the 90 kilowatt hour per square meter per year according to UN International Forum of Sustainable Development as the benchmark. So this is the result. Yeah, the most energy saving from the passive design implementation is the use of higher thermal performance class, following by reducing window to wall ratio, using external shading device, and the use of external wall insulation. Then the active design strategy is the most effective strategy for energy saving with the use of solar PV, energy efficient air conditioning, and energy efficient lighting. So after the implementation of passive and active design strategies, the combination at the study case building, which is VOZA office tower, the energy consumption is reduced by almost 56% from 136 kilowatt hour per square meter per year in the existing building to almost 60 kilowatt hour per square meter per year, which is even better than the 90 kilowatt hour per square meter per year target. Okay, so from this research, the conclusion are first, the active design strategies have the most impact to reduce energy consumption, especially in the use of renewable energy and energy efficient lighting system. Second, the use of higher thermal performance tests have the most impact to reduce energy consumption compared to other passive design strategies. Third, the implementation of passive and active design strategies are effective to reduce energy consumption of in the office building by more than 50%. Okay, so finally, we are at the end of the presentation. These are the references. Thank you, ladies and gentlemen, for your attention.